In this video, we'll showcase a project featuring RGB LED lights. This project demonstrates the power of the C programming language for electronics development. Watch how C can be applied to bring hardware to life, turning code into functional, real-world systems. The LED display consists of 16 rows and 16 columns of lights, creating a grid of 256 LEDs. The touchscreen interface, housed in a sleek metal case, allows you to easily control and customize the LED display. The touchscreen can be used to adjust the brightness, color, and flashing rate of the LEDs. You can also modify the words displayed by the lights. The touchscreen interface was programmed using a tool called Interface Designer that is included with the powerful and easy-to-learn CCSC compiler IDE. Hovering over Images on the left side shows all of the images that we used. Let's open up one of the images for editing. The Areas section of the right side shows where we selected areas that will be used for button presses and printing text. Areas have an X and Y value for the top left point and a width and height. Hovering over Windows on the left side shows all of the screens for the touchscreen. Double-click on a window to open it up for editing. The Window Images section on the right side shows all of the images that are included in this window. When loading, the window can call a function from an included file. Actions is where you can set the function that will be called when the button areas and text areas are pressed on the touchscreen. All of the areas in this window are set to call the same function called handle menu. The variable named area ID that gets passed into the function will have a different value depending upon the area that was pressed. Interface Designer has the ability to generate C code that can display and perform the actions specified in the project's windows. The generated C code can be compiled with the CCSC compiler IDE. More details about how to use Interface Designer can be found in another one of our videos. The touchscreen board is powered by a microchip PIC24E PEEP microcontroller. The microcontroller is programmed to manage the core functionality of this project. Now, let's explore some of the display options available through the touchscreen interface. One of the display options is Set LED Color. There are 8 preset colors that you can choose from. There is also an option to set a custom color by entering 3 values for RGB. Let's try green. Here is what the blue looks like. Let's finish with yellow. Here is the schematic for some of the RGB LEDs. They work by combining 3 different colors of light, red, green, and blue, to create a wide range of colors. Each RGB LED has 3 tiny light-emitting diodes, one for each color, inside a single unit. By adjusting the brightness of each diode, the RGB LED can produce various colors, including white. In our C code, we have a switch statement that checks which LED color should be displayed. Each color has a red, green, and blue value. The color variable is a special data type that we named RGB_T. This data type uses a union, which allows us to store an RGB color value in 2 different ways, either as a single 32-bit number, or as 3 separate 8-bit values representing red, green, and blue. The function Set LED Color loops through the LED boards and changes the color of all of their LEDs. There are 8 LED boards mounted to the wooden display. This picture shows the wiring in the back. Each board has 2 rows of LED lights. A modified version of West Mountain Radio's Rig Runner 4008H is used as the DC power distribution panel. Each of the LED boards are connected to the Rig Runner for power and to the touchscreen board for programming commands. The Rig Runner and touchscreen board are connected to a positive 5-volt 100-amp power supply. The left side of this schematic shows what is assigned to each pin on the LED board's microcontroller. For example, LED 1 is assigned to pin B3. The right side shows the schematic for daisy-chaining the LED boards. The green and white wires are daisy-chained to each LED board to simplify setup and reduce cabling. Those wires connect the LED boards to the touchscreen board. The grid will show an animation when Display Star Burst is selected. The C code for this animation will go through a series of steps in which it will turn on certain LED lights to create the desired effect. Are you interested in building a project using a touchscreen interface? If so, CCS sells a touch display development kit that includes a touchscreen board, an ICD programmer and debugger, cables, an exercise book, and the CCS-C compiler IDE, which comes with the Interface Designer program. For more information, visit ccsinfo.com/touchkit.